Okay, so this is the key to part E, and so you're given this function, and this function is called g of x. So this is my function g of x, and you want to use this graph to answer questions 1 through 4. So in number 1, you want to find the domain of this function using interval notation. All right, so remember the domain is a set of x coordinates. So you want to find out what are the x values that are associated with each of these points, and notice there are an infinite number of points here. All right, so the best thing to think about this is this way. So for example, is negative 4 in the domain? Well, yeah, negative 4 is in the domain because here's negative 4 and here's a point associated with it, and that point is negative 4, whatever the y value is, that point's negative 4. So negative 4 is in the domain. But there's some other x values in there. So notice this arrow, there's an arrow here, so it keeps on doing this, and same thing here, it keeps on doing this. And so then you ask yourself, all right, so to find the domain, I'm going to go along the x-axis just like this. And the question is, when I go along the x-axis, what is the smallest x value that's going to be associated with the point of the graph? So for example, this is, let's say, negative 100. So if x is negative 100, do I get a point of the graph? Yeah, there's a point of the graph associated uh, with a point where x is negative 100. But is that the smallest? No, it's not the smallest because, remember, it keeps on doing this. So I can say if x is negative 1 million, I get a point on the graph. So, so the idea is this. So in this case, the domain would be from negative infinity all the way. And then your question is, what is the maximum x value? So is it 2? No, because you'll notice that these points here have a x value that's larger than 2. So it's actually going from negative infinity all the way to, and then you ask yourself, is the maximum 100? No, because this thing keeps doing this. So 1000, there's a point on the graph associated with an x value 1000, and so on. So you're going from negative infinity. There is no maximum x value where this graph stops. So you're going from negative infinity all the way to positive infinity. And remember, negative infinity and positive infinity, you're always going to use parentheses. Okay, the range is a set of y values that are on this graph. So remember, when range, you go along the y-axis. So the question is this: is negative 5 right here, the y value negative 5, is that the smallest y value on this graph? No, because remember these arrows keep going down like this, and so negative 8 is associated in the graph. Negative 1000 has actually 2 points on the graph associated with a y value of negative 1000, and so on. So you actually go from negative infinity all the way, and then where does the graph stop? Is there a maximum y value? And there is, because this is it right here. That's where my graph stops, and that maximum y value is 3. Now this point right here with that y value of 3 is a point on the graph, so we need to use bracket when denoting that 3 that we're going to write. So you're going from negative infinity with parentheses all the way to 3 with a bracket. Now remember, always go from smallest to largest. So don't say 3 to negative infinity. Okay, so don't do this. That's incorrect. All right, you must go from smallest to largest. Okay. All right, number 2, you want to find the function value g of negative 4. So the question is, remember what this means is, okay, so this is g of x. So x in this case is negative 4. So you're asking, what is the y value when x is negative 4? So you locate negative 4 on the x-axis. That's this. You look at the point associated with it. That's this point right here. And so it's a good idea to label that point. Well, that point is negative 4 comma negative 2. And so the question is, when x is negative 4, what's the y value? Well, the y value is negative 2. So that goes here. All right, g of 3. So again, you go to the x-axis, you locate 3. That's 3 right here. And then the point associated with it is right here. And so it's a good idea to label that point. You don't have to, but it's a good idea to do that. So that's the point 3 comma 1. And so then I come back and answer the question. So When x is 3, my y value is 1. So that goes here. So only negative 2 goes here, only 1 goes here. Don't put the answer as 3 comma 1. That's not what they're asking. Okay, they want to know what's that y value. Only the y value goes here, not the point. Okay, number 3 says this. Find the values of x for which g of x is 1. And I gave you a hint. There are two values. Now remember, g of x means the same thing as y. So you're asked if you look at all these points here, and an infinite number of points, if you look at all these points, there are 2 points where you get a y value of 1. All right, so the best way to answer that is to actually look at the y-axis, because you are asked y is 1. So you look at the y-axis, and here's where the on the y-axis where you see 1. And so you use your ruler to help you. And so there are 2 points. Obviously, you knew this one already because that's the y value 1, but there's another one, and that's this one right here. And label that point. So you get that label says the point -1, 1. And notice that the question is, what are the x values when y is 1? Well, here are the 2 points where y is 1, and the x values are 3 and -3. So you put -3, 3. It does not have to be in that order. Okay, here you want to list the x-intercepts as ordered pairs. Okay, ordered pairs. So there are 2 x-intercepts. So here are your x-intercepts. Remember, the x-intercept is where the graph crosses the x-axis. So it crosses here, and it crosses here. And label the points. So because you do want to write as an ordered pair. So remember, no matter where you are on the x-axis, the y-coordinate is 0. So this would be -2, 0. So you're going to say -2, 0, and you're going to say 4, 0. Okay, so so you use this right here to answer questions 1 through 4. The number 5 has nothing to do with that graph. All right, so number 5, you're given this function h of x, and you want to find h of -2. So remember, this time you're given the equation. Here you're given the graph. So you answer these questions based on the graph. Here, you want to find this function value given the equation. So basically all you do is where we see the variable x, you're going to substitute -2. That's what that says. So to find h of -2, you're going to say -3 times, in parentheses, -2, and I'm squaring that, plus 2 times -2 minus 1. Now, using the order of operations, do not say -3 times -2 is 6 and then square that. Because remember, the order of operations says I've got to do exponents before I multiply. So -2 squared means -2 times -2, which is 4. So this is -3 times 4. And then let's just go ahead and do this. That'll be plus a -4 minus 1. And then so this becomes a -12. And then minus 4 minus 1. Now always make sure you add and subtract from left to right. So let's do this first. A -12 plus a -4 is a -16, and a -16 and a -1 is a -17. So that goes here, -17. Over here, same idea, where we see the variable x, you're going to substitute 3. So I get h of 3 will equal -3 times 3 squared plus 2 times 3, and then minus 1. So wherever I saw the variable x, I substituted 3. Again, same idea here. You're going to do the exponent before you multiply. So 3 squared means 3 times 3, which is 9. So this becomes -3 times 9. And let's go ahead and do this. That would be plus 6 minus 1. So -3 times 9 is a -27, plus 6 minus 1. And always go from left to right. -27 plus 6 is a -21, and -21 and a -1 is a -22. So -22 goes here. And so that takes care of the key to worksheet part E.